These are some basic spatial operations. The first three are the most common. We have clip, intersect, and union. Erase isn't as common, but it's still very useful. A clip is an overlay operation that uses one feature to serve as the outer boundary of another feature. Clip is commonly referred to as a cookie cutter overlay. If you have ever baked cookies, you might be familiar with the concept behind this operation. A polygon layer called the clip feature works like a cookie cutter when overlaid on top of a second layer, the input, which acts like the cookie dough. The output is the copy of the input layer, but with the extent and shape of the clipped feature. Here's an example of when to use a clip overlay. There has been recent degradation in stream quality. We want to figure out a correlation between the amount of trails within 50 yards and stream quality. A clip will help identify parts of a trail that is within 50 yards of a stream. We want our output layer to just include trails that fall within that 50-meter stream buffer layer. So we can see here that we have the two layers turned on in ArcMap. We have that 50-meter stream buffer polygon with our line trail features. After we perform the clip function, we are going to be left with just those clipped trails, and that will help us identify parts of the trails that are within that 50 yards of a stream. So why not select by location in this instance? Remember that the output of a spatial query is not going to change the feature geometry. This means it won't allow you to find the total length of the trails within the 50 yards of the stream once that function is complete. Clips are also common for reducing the size of your data set to some boundary. This is a scenario from Lab 9 where we want to create an output layer of all creeks that fall within the boundary layer. So looking at this slide here, the first thing that I want to do is go into my ARC toolbox and analysis tools and select clip. And then our input feature or cookie dough is the creek layer, and the clip feature or cookie cutter is the boundary layer. And you also, as always, want to make sure that your output feature layer class is saved to your working subfolder in your workspace. And then you would tell ArcMap OK to go ahead and perform that clip. The resulting layer or your output layer should now only contain those creeks that fall within your project boundary layer. So really quickly, I want to go over some differences between clipping and select by location. The main differences between select by location and clipping are that the select by location won't update the feature geometry in the attribute table, and that select by location isn't as precise as clip. A clip is going to preserve information only from the clipped output layer and only for the area of the clipping. The attribute table for the output layer typically contains all the attributes of the clipped layer or the input feature and none from the clipping layer or the clip feature. So if we're thinking about that prior example of clipping the creeks to the boundary layer, that new output layer is only going to have the features from the creek layer and no features or attributes from the boundary layer. Where you'll have both with the select by location. And another thing, as we can see here with this diagram, when we use that clip, you get a really clean cut. That boundary is a hard boundary, where the select by location, since we don't have that hard boundary and some features may be longer than others, it's harder for the GIS software to really create that clean cut without having the specified boundary and only having that location as a guide, and so you end up with these dangle edges. So intersect is an overlay operation that preserves overlapping areas. The output will only contain regions of all included layers that overlap. For example, if one wanted to know which areas in Redwood National Forest intersect with Humboldt County, the output of this operation would be a layer composed of polygons where these two map layers overlapped. The resulting polygons would retain the attribute information from each map layer. Let's look at an example of when you might want to use the intersect tool. Let's say that you're doing a study on the distribution of a rare fungal species, in this case, the bleeding tooth fungus. Not much is known about its distribution, only that it has been cited in the area. Ultimately, you'd like to create a map showing all the different places where it might exist, or identify suitable habitat for this species. First, you'll have to do some research and learn about habitat preferences. You discover that it only lives in areas of Klamath mixed cover vegetation. And then furthermore, it prefers Klamath mixed conifer stands and areas with annual precipitation greater than 50 inches. You then want to find areas that meet these criteria. First, you will need to go out and acquire some data. You need base layers like California and county polygons, vegetation, and precipitation. Once you acquire these data layers, you will then perform different types of spatial queries where you will limit your data to just show California and then the polygons for vegetation and precipitation that are within California, like we can see here. Represented in blue is our vegetation layer, which was found on the U.S. Forest Service data website. Here we can see our precipitation layer, which was found from CAL FIRE's Fire and Resource Assessment Program. So now that I have everything that I need, I'm going to start my spatial analysis. So first I want to create my Klamath mixed conifer layer and my precipitation greater than 50 inches layer, both of which can be done by a spatial query, select by attribute. So as we can see here in our slide, the precipitation is represented in blue, where the Klamath mixed conifer is represented in green. And basically, like from both of those original layers, you're going to select just the Klamath mixed conifer polygons and create a new layer from that selection, and then do the same thing for precipitation for any areas that have precipitation greater than 50 inches in a year. So as we can see, there's quite a bit of area where there's greater than 50 inches of rainfall. Again, that's represented in blue. And so this is where I would want to intersect my Klamath mixed conifer and precipitation layers to create an output layer where the feature set would only include areas of Klamath mixed conifer zones that have an annual precipitation rate greater than 50 inches. So I would go into ARC Toolbox, go to Analysis Tools, select Intersect, and then input my two layers that I want to intersect, which is, again, that Klamath mixed conifer and the precipitation of greater than 50 inches. And of course, that output layer is going to be going into our working folder. And we're going to tell ArcMap to go ahead and perform the intersect. And here we have our resulting layer of suitable habitat for the bleeding tooth fungus. We can also see here that with an intersect, the attribute table contains data from both input layers. So here we have that Klamath mixed conifer layer information, and then here we have that annual precipitation information as well. Really quickly, let's go back to wanting to select any trails that are within a 50-meter stream buffer from our Lab 9 example. So the intersect tool can combine two layers with different geometry types. So here we have a line on polygon intersect. So by default, the output will match the lowest dimension geometry for your inputs. So basically that means your geometry for that streams buffer is going to be greater than the geometry for that lines buffer. So you have an area for that stream buffer, and then you have a length for the line features, and so ArcMap is going to default to the lines. So how is the output different from the output of an intersect? Visually, they look exactly the same. The difference will be in the attribute table. So again, with the clip function, you're just going to have the attribute data from that input layer, and then with the intersect, you're going to have the attribute data from both of the layers that you're intersecting. A union is similar to an intersect.